Good evening, ladies and gentlemen. This is Mr. Lang. I'm going to take you through the Chapter 9 pretest key. So starting right off the bat with number 1. On number 1, they're asking you to find the domain and range. So domain, I like to think about it as west to east, side to side. That's the x-axis right here. So if you're going to ask yourself, how far west would this drawing go strictly, and how far east would this drawing go? Well, if you think about it, they would continue on and on and on, and it would continue on and on and on and on. So those would go on forever. So any number is possible sideways, so we'd say all real numbers. Or you can do this symbol, that's kind of like a paragraph symbol turned into an R. However, the range is very different. If you ask yourself how far up can this go north versus how far south can it go? Well, this cannot go any further south than this number right here. So the lowest it can go, that minimum value, is -5. So basically it can be -5 and higher. It goes up forever. So how do we write that? We'd write y is greater than or equal to -5. Or you could have it reversed. -5 is less than or equal to y. All right, number 2. All right, they give us the picture and ask us a bunch of questions. Identify the vertex. Well, there it is. And the vertex is a point. So it's asking for both the x and the y. So that point there is -2, 6. And then it says, is that a maximum or minimum? Well, that is as high as it can go. It can't go any higher than that. It's kind of like an imaginary ceiling. And when it says what is the value, it's asking what is the max height? How high is that ceiling? Well, that would be the same as the y value of the vertex, the 6 right here. That's how high it could go. Moving on to number 3. All right, let's find the axis of symmetry. Everyone should have this one memorized by now, the opposite of b over double a. Don't forget that it's x equals, all right? Don't forget that x equals, because the axis of symmetry is a line, and you need x equals to represent a linear graph. So the opposite of b over 2a, so in this problem, it would be actually +8 divided by 2 times 2. So that would be 8 divided by 4, which would equal 2. So we'd write x equals 2 is our axis of symmetry line. All right. The next one, they want us to solve this, but notice they say by graphing. Well, we did a lot of these word problems where the idea is what goes up must come down. And then the question is asking us how much time, which is typically the x-axis, what is the spot here where the object returned to the ground? So in this problem, I notice on our equation right here, we have our A, our B, and our C. Wait, there is no C. So this is one of those cases where we actually know that the y-intercept is kind of the beginning, that the object starts on the ground. We know it goes upward from there, but actually if you notice, it doesn't ask us how high. The maximum is not the question here. The question says, when will it return back down? When will it return back down to the ground? So there's kind of this imaginary, we're not necessarily sure how high it goes, but when would the object come back down? Well, we're going to go old school and still use the axis of symmetry formula. So in this case, you got to notice that b is 64, so it would be -64, the opposite of 64, divided by 2 times -16. So that would be -64 divided by -32. So the AOS is +2, but remember that is just our axis of symmetry. But the question is asking us, when would it come down? Well, if it's 2 seconds to get halfway, we kind of assume it's another 2 seconds until it would hit the ground at 4. So our answer would be approximately 4 seconds. Another way you can do this for reference is we learned later with reverse FOIL and factoring that we can kind of think, when would our equation equal 0, right? If it equals 0, that's where the ground is. So I notice that I only have two terms and that there is quite a bit that they have in common. So these both have negative 16 and an x in common. Well, what would be left behind then, if I took out a negative 16x, that would just leave me with the positive x. But the 64 taking out the negative 16 would actually turn into a negative 4. Oh, how obvious. What minus 4 equals 0? Oh, so x would also be positive 4. So just another way you could solve this problem. All right, number 5 and number 6 is where we start solving. There's that word. We actually want to know, what is x? What is x? What is x? What is x? All right, however, it's asking us to use factoring. Well, luckily, this problem, they're already factored for us, okay? Now, using the zero products property, the idea here is that this green chunk could equal 0, or this pink chunk could equal 0, either or. Now, this one you could probably do in your head without showing your work. You could do all this, solve, blah, blah, blah. Hopefully, you just know that 3 minus 3 is 0. So one of my answers is 3. But the other one, you might want to show your work, because 3 times what subtract 4 equals 0? Well, if you can't do that in your head, just a little bit of simple algebra. I'm going to add the 4 to the other side and get 3 times what equals 4, and then get x by itself, divide by 3, divide by 3. And there is my answer, x equals 4 over 3, or 1.6 repeating. All right, what's more difficult about number 2 is that this one is not in factored form. It has not been factored for me. So this one, I got to think about what multiplies to be negative 27 and combines to give me a negative 6. So check mark on the x squared. Check, check. I know those are good. But then my negative 27, let's see, I could have negative 1 and positive 27, or 1 and negative 27, or 3 and negative 9, or negative 3 and positive 9, and that's it. So check on the negative 27. It's got to be one of these combinations. And now I'm just going to see which ones, if I combine them sideways, will that, no, that'd be 26. That one would be negative 26. This one would be negative 6. Oh, there's my winner. So it ends up being a positive 3 and a negative 9. However, remember, those aren't the answers. The answer to this chunk is what would make it 0 is if x was positive 9, and what would make this chunk 0 is if x was negative 3. So there's my two answers, negative 3 and positive 9. All right. Key word here for these, it says find the zeros, solve again, but algebraically using square roots. All right, so basically what they're saying is, can you get x by itself and also use square roots to solve? So I'm going to minus 16 from both sides. Trying to get x by itself here, I get 9x squared equals negative 16. I'm going to divide by 9. Some of you might already see the result here. So I end up with this awkward x squared equals a negative 16 over 9. So not only is that a fraction, but keyword here is it's a negative 16. So when I go to take the square root to get x by itself, nope, can't have that negative sign in a square root. So this one would be a no solution. All right, next one, I can solve this one. I'm going to add 64 to both sides. Get 2x squared equals 64. I'm going to divide by 2. Actually, I can do that, right? 64 is an even number. Divide by 2, so I get x squared equals 32. Yikes. I do not think there's anything evenly times itself that equals 32. However, You just have to use your calculator on this one. So the square root of 32 equals approximately plus or minus 5.66. All right, if we go to the nearest hundredths point spot, or if you said approximately 5.7. And do not forget your plus or minus. It was x squared, so when you take the square root, you should get two answers here. Don't forget the plus or minus sign. All right, we're flying. Only a couple left. Number 9, solve using the quadratic formula. If it were me, I would just write that out really quick. Negative b plus or minus the square root of b squared minus 4ac all over double A. Alert. This equation is not in the proper form to begin with. So I'm actually going to have to add 9x over to the other side and put it in the proper order. So first of all, I need to write 2x squared plus 9x plus 4 equals 0. So now I'm good, I equal 0. So now this formula works. All right, check. It would not work unless I had the original equation equal to 0. So let's just plug in our A, B, C's here. So we're going to get negative 9 plus and minus the square root of 9 squared minus 4 times 2 times 4. All of that divided by 2 times 2. I'm going to solve my square root chunk first according to PEMDAS. So I'm just going to do that on the side. So 9 squared is 81. Negative 4 times 2 is negative 8 times 4 would be negative 32. I end up with that equals 49. Hey, look at that. How about them apples? That equals a perfect 7. So I'm going to take that 7 that I solved from the square root chunk, trade out the entire square root chunk, and I'm left with negative 9 plus and minus 7 divided by 4. So my two answers will be, what, negative 2 over 4. And if I added, or if I subtracted, I get negative 16 over 4. So that would be x equals about a negative 1/2, or x equals negative 16 divided by 4, negative 4. All right, almost there. This question is just asking about the discriminant. So that is part of the quadratic formula. It's just talking about that square root chunk, especially those numbers underneath. Hopefully that alert triggers in your mind. This one is not in standard form. We give you that hint, so you have to subtract 44 to the other side. So we write x squared minus 7x plus 44. Minus 44. Little righto there. Doesn't want to erase. There we go. 7x minus 44. Key to have that negative, because now when I do the discriminant, I have the square root of negative 7 squared. Well, that's going to be positive 49. But it's negative 4 times 1 times negative 44. So I notice I have two negatives in this multiplication over here, so it should end up equaling a positive. So I get the square root of 49 plus 44 times 44. I'm blanking on that 1 second. So that's 176, and so you add those and it equals the square root of 225, which we know actually would work, and that's 15. But when it says the value of the discriminant, it's actually just talking about what did you calculate on the inside. So that would be just that 225. And since keyword that's a positive, you know you'll be able to continue and get two solutions. And how about that? Now it actually wants to find the solution. So we basically are giving you a hint that there will be an answer. So I just need to finish the rest of this quadratic formula. So it would be positive 7 plus or minus that 15 I calculated there divided by 2 times a, which in this case it'd be 2 times 1. So I get 22 over 2, so x equals 11. And I get negative 8 over 2, so my other answer would be negative 4. All right, last one, and this one was kind of tough because it's not going to have pretty zeros. That's always the goal, but if it doesn't work, sometimes we have to just trade out our zeros and we have to pick our own points. So I'll show you at the end why zeros are not a good choice in this problem. Regardless, we always start at the beginning, opposite b over double a, so in this case it would be positive 6 divided by 2 times 3, 6 over 6, which equals 1. So my axis of symmetry, all right, is going to be at positive 1. Do this in a nice bright color so you can see it. All right. I saw a few people today accidentally reflecting over the y-axis, so we want to be careful. So the axis of symmetry is x equals 1. Well, we know our vertex is going to be on the axis of symmetry, so it has the same x number. So we just have to plug 1 in there and there. So we get, I'll do my work down here, 3 times 1 squared minus 6 times 1 minus 2, so 1 squared is 1 times 3 is 3, 6 times 1 is 6, so minus 6 minus 2, so I get negative 3 minus 2 would be negative 5. So positive 1, negative 5. Then I'm going to jump right to my y-intercept, which is my c number, is my y-intercept. That's our freebie, but technically it's 0, negative 2. So that's up here, reflect it over 1 to the here, so 1 to the AOS, so 1 here, so there's the actual point. So this is what I was warning you about. I can kind of tell just as I begin my sketch that my zeros are not going to be perfect. They're going to be decimals. I can see it. So again, we're not going to use zeros. Instead, we're going to pick. Well, we can tell that eventually it's going to go somewhere where x is 3, so that's just my choice. It doesn't have to be 3. It was just the next one to the right, just keeping my drawing going. So if I plug in 3 into the equation, the same original equation, 3 times 3 squared minus 6 times 3 minus 2, I actually get my answer to be positive 7. So this is a super skinny graph because I have 3, 7 all the way up here, and I go 1, 2, 1, 2 to the left. Reflect that point over. So now if I actually finish my drawing, it has to be like super, super skinny parabola. All right. So we can tell our zeros are not nice numbers. They're in the middle. Okay, so if this said solve, we had to find this out. Again, if it said solve, you would have to find those, but this problem didn't just say solve, it only said graph. All right, so we have to make that executive decision. Thanks. Good luck on the test, everyone.